This is parts of an experiment notes. Our objective today is to identify independent variable, dependent variable, control group, and experimental groups. So these are the 4 words that we're going to concentrate on, and we're going to do some practices. So, why is this applicable? Well, this is going to be one of the most important things that you learn, and we're going to come back to it throughout the whole class because these are essential for scientists to get valid results. If a scientist do an experiment and they don't use these things properly, they will not get a good experiment, and their results will mean nothing. Not only that, but we use these every single day just without thinking about it. In sports, every time you go out and practice, you might conduct a little experiments. If I hold my hands like this on the bat, if I kick the ball this way, what is it? How does that change the outcome? And that is basically what an experiment is. We change one little thing, and then we look at what the outcome is. We do it a couple times and see if there's a good or bad outcome or whatever the outcome is. Your car doesn't work, so the mechanic will do a series of tests. He'll try one little thing. If that didn't work, then he'll try something different. And the key thing in all of this is that we try one thing. With the recipe, we can bake something one way. If that doesn't work, then we might have to bake it another way, change one little ingredient, and see if it tastes better. Beating a level on a video game. All these different things, you're going to go through trial and error. You try one thing, if it didn't work, you'll go back, try it again with changing another thing. And that's basically what an experiment is. So that thing that you keep changing, that one thing, now again, it's key that you only change one thing, is called the independent variable. So in the video game, you might change one strategy. You might do one little thing different and to try to beat that level. If that doesn't work, then you might go change something different. But again, you only need to change one thing. If you change 2 things, and then it worked out, well, that's good, you go on to the next level, but you don't know exactly how you beat that level. Was it the one thing that you did, or was it the other thing that you did? Same with baking. If you change 2 ingredients at a time and then it tastes better, then you might not know which one made it taste better. Was it both of them combined, or was it just one or the other? So you have to change one thing at a time. Alright, so it's what you're testing. For your notes, you can write down any one of these things. A good thing, so we have the definition here, it's what you change in experiment. How you can remember it, so I or I change, it's one thing you change, or it's a thing that you're testing. So that's the independent variable. Now, the big confusion with the dependent variable is a lot of people say, well, if the independent variable is what you do change, the dependent variable is what you don't change. But remember what variable means. Variable means to change. So this is still a variable. It's still something that changes. However, this is what changes due to the independent variable. So if you change what you did in the video game, and then you beat it, the dependent variable is you beating it or not beating the level. It's what depends on what you changed. The recipe, it might be whether it tastes good or bad. That's the dependent variable. It depends on what ingredient you changed. All right. It's also usually what you measure. So you would measure the taste. You measure the you beating the game by beating the game. You can measure if your baseball swing is working better. What you change about your baseball swing by how far the ball goes or how much you hit, how often you hit the ball. All right. So again, it's what changes due to the independent variable. It's also what you measure, and how you can remember it is D is for depends, so it depends on the independent variable, or D is for data. All right, it's the data you collect. So when we talk about tables and graphs, it's always going to be the data that we collect on the experiment. Now the next 2 kind of go together. There's a control group and there's an experimental group. So when you set up an experiment, you're going to have different groups and you're going to change one thing between those different groups. So if you're trying a new recipe, you might cook it 3 different ways, and each way is a little bit different. You change one ingredient. So maybe you put sugar, a teaspoon of sugar in one, a tablespoon in the other, and 2 tablespoons in the third. So you change just how much sugar you put in each one. Well, one of those has to be your control group. You have to compare what you were doing to something so you know if it tastes better. So what you would do is you take that original recipe, you taste it first, and then you make your other two recipes, and then you would taste those and you would compare it to the original recipe to see if it was good or bad. If you didn't do that original recipe and you just change it, you wouldn't know if your changes for the better or for the worse, because maybe it would have tasted better with the original recipe. You don't know. So you need to do that original thing first. Same with anything else, like batting practice. Again, going back to the baseball example, you could have your original swing, and then you might change it. But if you don't compare it to that original swing, like if you don't record like how many hits you get after 50 pitches, then you won't know if your new swing is going to be better to that original swing. So you have to record that data. So the thing that you're comparing it to, that original group, that is the comparison group, that is the control group. It's also usually the one without the independent variable. So if we're testing, a example I always like to use is fertilizer, and we have one group with fertilizer, one group with no fertilizer, and one group with twice the amount of fertilizer. The one without the independent variable, so we change the amount of fertilizer between those groups. The one without the independent variable, the one with no fertilizer, is your control group, and I'll show you that in the practice. And then how you can remember it is you can put no in front of the independent variable, since it doesn't have the independent variable. So you just put, if the independent variable is fertilizer, you just put the word no in front of it. All right, experimental group are all those other groups. So down here, if you're testing what pH best curls your hair, you would use a neutral pH as your control. But neutral is 7 in the middle, and that would just be like water. And then you would try various different pHs to see if any of those make your hair curl better. And it would be, you can try 2, 3, 4, 5, 6. So experimental group are just all the other groups that are not the control group. All right, so let's do some practice. So example 1. All right, you guys can read that. I'm not going to read it. But if you look, the first thing I always do is I look for my groups. So if I look here, we have pot 1, we have pot 3, pot 4, and pot 2. All right, so there's 3 of them. All right, right here I tell you which one was used as the control. So pot 2 was used as the control because it was watered with the recommended amount. So since that was a recommended amount, that would be our control. So I'm going to put pot 2. All right, and here's pot 2. So 75 milliliters. So that means the other groups, our experimental groups, were 50, 100, and 125 milliliters, or pots 1, 3, and 4. It doesn't really matter which one you put for that. The independent variable, so what did we change between these groups, is the amount of water that we added. All right, so that's what we're testing, the amount of water. And the dependent variable is what data we're going to. So all the pots received the same amount of sunlight. The student recorded the heights of the plants. All right, so the height is going to be the data, or what depends on the amount of water. The height of the plant is going to depend on the amount of water that we have. So that's the easiest way to do that. You can also just read the experiment, figure out what they change, then go back and do the groups. It doesn't really matter which way you do it. All right, so now we're going to go on to one more example. All right, so a biology student prepared 5 2-liter beakers of water at the following temperatures. Those are your temperatures. Temperature in the aquarium of their classroom was 22 degrees Celsius. They removed the goldfish from the aquarium and placed 3 in each beaker. For 5 minutes, they counted and recorded the number of times the gill covers opened and closed. All right, so again, if you look at our groups, we have 18, 22, 26, 30, and 34. So what's different between those groups? The temperature. So we were trying to see how temperature affects the goldfish. All right, now how are we going to see if the goldfish was affected? Well, they're counting and recording the number of times the gill covers opened. Whenever a gill cover opens, that means the goldfish is breathing. So if you put down gill covers open, that's fine. But I'm going to put down breathing. So that's really what we're measuring. All right, the groups over here are 18, 22, 26, 30, and 34, and then it says the temperature of the aquarium in their classroom was 22 degrees. So that would probably be the normal temperature. You can't have no temperature, so that would probably be the normal temperature. So the normal temperature would have been your control group, or 22 degrees. So you're going to compare how the warmer and cooler temperatures affect that. So 18, 26, 30, and 34 are going to be your experimental groups. All right, so these are things you're going to have to master before you move on, and we're going to constantly come back to these throughout the whole class. So it's very important that you master these: independent variable, dependent variable, control group, and experimental group.